Thank you, and welcome, and thank you for joining us. Yeah, I'm Jason Elsinger, and I'm joined today by at least a few of my current BC calculus students, Ayden, Cassandra, and Duncan. And what I'll do here is I'll introduce myself a little bit, describe a bit about our school, the class, how differential equations relates to the AP exam, and then some of the models I've sampled from the SIMIODE text to get at some of those topics. Then I'll give the floor to some of the students to introduce themselves and to describe their experiences working through these models. So previous to now, I was an assistant professor of mathematics at Spring Hill College and Florida Southern College for a combined 10 years. And beginning last year, I came to Jordan High School to teach advanced placement math courses. Jordan High School has around 2,500 students, and I'll note that the classes are on a semester schedule, just like at the college level, but the semesters are a few weeks longer. The Advanced Placement BC course is run as all 2 semesters, where the first semester is essentially Calculus 1 plus a little bit of volumes and area between curves. And then the BC portion happening now is essentially everything else that's in Calculus 2. This year, we happen to have a small section, about 13, and they're all excellent students. So just very happen to be very fortunate that we have a small group. So it's much easier to do some exploratory things and get into some fun experiments. Also note that our contact hours are a lot more than at the college level. We meet every day for an hour and a half, Monday through Friday. I did teach BC last year, and I taught it at the usual sort of rate of topics, which I'll describe in a moment. And I did not use modeling as an application last year, so this was really cool to switch it up this year. On the AP exam, differential equations does form a unit. And as you see, it's roughly less than 10% of the BC portion. And just from sampling some models from Chapter 1 and Section 2.1 from the SIMIODE text, we were able to go over all these topics except slope fields and Euler's method. I wanted to show a few questions, examples from AP questions. So when I look through the bank of questions I have to give students for practice, there are some modeling type questions up there. And here's an example of one that describes the rates of the weights of these baby birds. And sort of given the DE and then asked a few questions about it, which is essentially their understanding of derivatives. Plug it in, describe increasing, decreasing, and then maybe do some integrals to do a separation of variables. Here's another example that requires a calculator, which kind of has this mixing problem sort of feel to it. We have a tank and rates are coming in and out, and both rates are variable, and students are meant to use Desmos to put together an integral to describe the number of gallons in the tank or intersections between these curves to find the minimum. And while these questions are certainly interesting, they're sort of abstract in a sense. In this one in particular, these expressions for the rates seem sort of made up, even though it's kind of interesting. They're turning on and off over time. But there's not really any description of the assumptions that were used in the description of the tank or the birds and why the model given makes sense for those assumptions. There's no thinking about the validity of the model or those assumptions. And those are sort of skills that usually students don't really get to till the college level. Um, Usually, when I teach differential equations, it comes after going over some integration techniques first, and then I would normally go over a standard question like this, describing how to separate the dx and the dy, and then you can use those techniques to integrate both sides, and then find the solution to this given some initial condition. But here, what I'd like to do is to reverse the process, to start off with some real-world situations, see the derivatives showing up and then from that motivate why we'd want to do integration techniques. So some of the models that we did sample from, the first one was a model for medicine delivery into the inner ear. Since it's sort of liquid filled, it's kind of like a tank mixing problem. We have sort of the medicine coming in, it mixes in, and then it leaves the ear. We're replacing the inner ear liquid with another liquid that has this sort of medicine in it to help it function better. And from this, we reveal this differential equation that seems at the surface just as complicated as the previous problem, but now it's connected to something. And what was neat about this question was that there are some rates, concentration, so there were some units that we had to talk about. Microliters was something we had in there. So the micro was a conversation. And it was interesting to relate these sort of real world units to the math symbols that were describing them. Um, Another model we did was describing population growth, and in particular, human interaction with that via harvesting in the population of fish, for example. And it was just pretty nice. We first went over, the usual exponential growth model, and then we built from that how to incorporate the environment to get the logistic equation, and then from that, the interactions of how the harvesting changes that differential equation. And what was cool about this exercise in the text was that it came with some real world data that once you plotted it, the task was to kind of find uh, values of the parameters to sort of fit that data. And that was a real nice conversation to have around what that means, parameter fitting. And at the end of it, it certainly left open a question of how to find those parameters maybe in a more efficient way. Still left to do is to solve that logistic equation, which I look forward to using this as motivation later on for partial fraction decomposition. Another one we did was ant tunneling. And this is an interesting task where students are thinking through what functions might best describe the time it takes for an ant to dig out an incremental part of a tunnel. And the last one we did was Newton's law of cooling, which I like to pose as, what was the time of death? Because I don't think students realize they come in that day, we're going to be detectives. So these are all great models that I thought were very nice to introduce real worlds, rates of change descriptions that are relatively easy to solve by hand using the same techniques that are required on the BC exam. One thing left to do also is I think one of the sections I'll do even after today's talk is the air resistance section as a way to introduce how hyperbolic tangent sort of shows up in the solution to that. Previously in a homework assignment, I did have students explore the differential equation for a hanging chain and the steps for how to solve it. And from that sort of reveals hyperbolic cosine. So I'm excited to sort of show some of the hyperbolic functions showing up because these are examples of some new things that the students are seeing. All right, awesome. Well, without further ado here, I'll start to introduce the students. And I know I saw Gall and Cassandra. I'm not sure if Ayden and Duncan are with us today. Oh, I see Ayden's there. Awesome. Well, yeah, I'll go ahead and give a short. If Duncan is there, you can go ahead here. And what I'll do one by one here is give you a chance each to say hello, describe yourself a little bit. There's a few things here on the screen, but feel free to say a few things about what you like to do and your plans moving forward. All right, Duncan, are you there? Yeah, Duncan had a AC test this morning, so it's possible he wouldn't join us. That's fine. Ayden, are you there? You can go ahead.
I am. I'm in 11th grade. I do swimming and some water polo. When I grow up, or what I want to do in college is I want to go into engineering because I really like math, really enjoy it. Um, and I have a Max Town Hall 13, if you know what that is. Probably not, but it's fine.
I did have to look
And
it
that's
up.
me. That's
That's
about it.
awesome. All right, awesome. Gall, go ahead.
Um, Wait, one sec. Um, my name is Gaul. I'm an athlete. I also do swimming and water polo, and I'm interested in going into electrical engineering. And a fun fact about me is I can solve a Rubik's Cube blindfolded.
Awesome. And Cassandra?
Hi, I'm Cassie. Um, I'm in 11th grade, and I want to go into climate science or something else environmental, which involves a lot of modeling. So,
Yeah, that's awesome. Yeah, welcome. So I guess what I'll do here is we have a bit of time left. I'll have a few thoughts that I can give on sort of how it went, but I thought it might be more interesting to make sure the students have some time to talk about some things. I have a couple questions that I ask the students to think about a little bit. So maybe we'll start with a few of these. And if there are any questions in the from the audience, we can certainly ask those as well. But maybe to get started, if we would, in the same order that you introduced, is there a certain model that we did that it described that you thought you liked the best? And in particular, did it speak to what you wanted to do at the college level? Okay, Ayden?
Um, I found the cooling example the most interesting, even though it's rather grim. It was cool to see how it's like actually used in real life and like how people really do use stuff like this in their day-to-day lives. Their job.
Very nice. Go.
So I also found the Newton's law of cooling one of the most interesting. It was a very like interesting topic that I didn't know much about, and it like allowed me to practice solving differential equations with two missing variables. I don't know if it's particularly like connected to electrical engineering, but I think it like really got me thinking like an engineer and scientist, which helps.
Oh yeah, great point. And Cassie?
Uh, the scenario I found most interesting was the fish harvesting one, but I think my favorite was the cochleo, the ear one, because of how weird it is, and so it's easy to remember and connect it with.
Great. That's really great. Well, how did you feel about the book? If you got a chance to kind of, we did do a little bit in class where we went through the cochlear implant one, but if there's other parts of the book that you read, how did you feel about it, the way it was structured, and were you interested in kind of learning more from it? Ayden?
Um, Wait, what was the last part of the question? I'm sorry, I
Go back.
it cut out.
Yeah,
I think.
if there's, your interest in learning more modeling, different applications. How did that book help out with that?
Oh, yeah, I love learning about the modeling and the applications. I'd be very excited to learn more.
Did you get a
Um,
chance to read the book much?
oh yeah. The the book was also great. I mean, for the same reasons. I really liked the scenarios, the stuff. I mean, learning not just the equations, but the modeling and what they're used for,
Hmm.
like how people make stuff with them.
Yeah, I see. Yeah, feel free to give some other thoughts too. Gall?
I really enjoyed the book. I thought it was understandable, and with all the vocabulary and specific scenarios they used, I thought it like immersed me into the math and allowed me to visualize it better, so I know what I was doing.
Hmm. Yeah, the only one was the cochlear one had some bigger biology terms in there, but it was very easy to kind of see around that and what was happening, just that liquids being replaced and removed. So it was very easy to see. But yeah, other than that, that's great. And Cassie?
Yeah, the descriptions of the scenarios in the book were very very detailed and went into describing what the looked like, and so that was helpful in conceptualizing it.
That's really good. Yeah, I think I will use these things kind of in the future. This was a lot of fun. So yeah, so really glad to sort of do this and looking forward to doing it some more. Happy to take a few more questions, but we're essentially done. So I thank you for joining us.